Okay, in this video I'm going to explain why perpendicular lines have opposite reciprocal slopes. Depending upon where you are in math, some of these concepts might be a little bit more advanced than what you're used to, but I don't think we see this enough. People just tell you that perpendicular lines have opposite reciprocal slopes, and you don't really have a grasp as to why. So I want to show you why. If you've gone through and you've done Algebra 1, or if you've gone through and you've done Math 0314, if you're in college, these topics are within your grasp. If you're in the middle of taking a course, then my advice to you is to watch this video, maybe have an idea of what's going on, try to grasp it, and then take a look at this at the end of the semester and see if it makes more sense. Okay, but I'm a big proponent of never, one of the biggest lessons math has taught me is I don't accept things because someone says so. You have to prove to me, you have to show me why it's true. So in that tradition, I want to explain how to do this. So a couple things you're going to need to know in order to do this. You're going to need to know the distance formula, Pythagorean theorem. The truth is, the distance formula is Pythagorean theorem. But let's go through it. Let's see why this is the case. Okay, so this is, again, I want to emphasize that this is going to be very labor intensive, so be ready to work. Okay, so the first thing I want you to realize is that I drew a picture and these lines are perpendicular. If these lines are perpendicular, perpendicular lines form a 90-degree angle. So this angle is 90 degrees, this angle here is 90 degrees, this angle here is 90 degrees, this one here is 90 degrees. We use a little box to indicate 90 degrees. Okay, so what do I know here? Well, I took a random point. I'm going to use 1 here. I could use any point, but this is 1. This point here is 1 comma y1, and this point here is 1 comma y2. So what I want to do now is I'm going to figure out this distance right here. Okay, so that distance right there, I'm going to use the distance formula here. It is just the difference of y1 minus 0 squared plus 1 minus 0 squared. And this will give me the distance of the first one. Okay, I'm going to call it line 1. So line 1. So the square root of this will give me the distance of line 1. Again, I want to show you what I'm doing here. This is going through the origin at 0, 0. And so we have y1 minus 0, and then 1, right, minus 0. Okay? I'm going to do the same thing. Let me do it in a different color here. I'm going to do the same thing for this line too. Okay? So this will be the square root of y2 minus 0 squared plus 1 minus 0 squared, and this will give me line 2, the distance of line 2. So if we solve this, the first one is just going to become y1 squared plus 1 squared, which is 1. The square root of that is line 1. And for line 2, the distance would be the square root of y2 squared plus 1, and that will be L2. Okay. The next move, and this is the ingenious trick here, is that we've made ourselves a right triangle here. So with a right triangle, I can do Pythagorean theorem. Pythagorean theorem is a squared plus b squared is equal to c squared. So line 1, the distance of line 1 is, I think I called it a squared. Yep. That's a. So, sorry about that. So that's going to be the square root of y1 squared plus 1. And I'm going to square it. For consistency, let me rewrite this one here as parentheses as well. Okay, so plus, we're going to do y2 squared, and And this is going to equal to, I'm running out of space here, but this is going to equal to what? This is going to equal to this distance here. Well, what is this distance? This distance is the difference between y1 and y2, right? So that if I take whatever this value is and I subtract this value, that gives me this distance. So y1 minus y2. So this equals to y1 minus y2, that distance squared. So now we have an equation. So I'm going to take this equation and I'm going to go ahead and solve it. So this part here just becomes y1 squared plus 1. This part here becomes y2 squared plus 1. And this part here I'm going to have to FOIL. So foiling means I'm doing y1 minus y2 times y1 minus y2. Some of you all have some experience with that. I'm going to do this fairly quickly. It's going to become y1 squared minus 2 y1 y2 plus y2 squared. And let me explain why. So, pun intended. So this is the same thing as this. And so we multiply these two together. This gives me y1 squared. Multiply these together, we get negative, because you've got the negative sign here, y1, y2. Multiply these together, you still get negative y1, y2. Don't get confused, y1 times y2 or y2 times y1 are the same thing. And the back part is plus y2 squared. So if I consolidate terms, I get y1 squared minus 2. These are the same, so you get two of them, y1, y2 plus y2 squared. Okay, so that is this bit right here. Okay, so moving right along, we have 1 and 1, we can put those together, so we have y1 squared plus y2 squared plus 2, and y1 squared minus 2y1 y2 plus y2 squared. We're going to have space. Now, the trick here is to realize that we have y1 squared here and we have y1 squared here, so they're going to subtract out. And we have y2 squared and we have y2 squared. Those are going to subtract out. So we're left with 2 equals negative 2 y1 y2. And when I divide through by negative, let me divide through by negative 2 first. I'm going to get negative 1 equals y1, y2. It doesn't matter which one you honestly take. Let me go ahead and take y1. And this is negative 1 y1 equals y2. And 1 over something means reciprocal. The negative sign means opposite. So we have opposite reciprocal. Keep in mind also that the distance from the original problem here, this distance and this distance are actually the same. So there you have it. Notice it doesn't also matter where this is positioned here. This could be 1, this could be 2. It doesn't matter because down here, right here, on this move here, they would divide out no matter what. So it would still become 1 no matter what. So hopefully that wasn't too bad, but that's the reason why perpendicular lines have opposite reciprocal slopes. Keep in mind also this is just one proof. There's actually a lot of different ways of showing this, but I don't think it's shown enough why this is true. So there you have it. Hopefully that was exciting, and I'll see you in the next video. Okay guys, one last note. Instead of making another video or editing this all out, I figure I'd just add this one little stipulation here just to be clear here. When I was solving here and I get, say, 1 over y1 equals y2, just want to stress here that the slope of the first one, right, is going to be, the rise is y1, the run is 1, and the slope of the second one is y2 with a run of 1. Okay, So that's why we can say here at the end that it's opposite reciprocal slope. Take note here that y2, I understand that the way I've written this, it's a negative, but I'm calling the value y2. So the negative value is implied inside the variable, if that makes sense. And that's why this is sufficient for the final answer. So hopefully that doesn't confuse you. And thanks for watching.